Hey everyone, this is Rob with Codecademy. I'm a software developer based out of Seattle, Washington. And in this video, we're going to walk through the C# project Moneymaker. So far we've learned about numerical data types and how to work with numerical data in a few different ways. To complete this project, you'll need to be familiar with using arithmetic operators to write expressions, using built-in methods to do more complex math, and collecting user input and using that data to solve a user's problem. Let's get started. Alright, in our Moneymaker project, we're going to have three types of coins. A bronze coin worth 1 cent, a silver coin is worth 5 cents, and a gold coin is worth 10 cents. Now the question we're trying to solve is what is the minimum number of coins that equals 98 cents? So we're given a simpler challenge down below just to see how many coins it would take to make 16 cents so we could get into practice. Now we could easily solve this with 16 1-cent coins, or a better solution would be to use 3 of the 5-cent coins and then a 1-cent coin. But the best option is going to be this last one, where we use a 10-cent, a 5-cent, and a 1-cent coin for a total of 3 coins. Now to get through this project, we're going to need to be comfortable with division, rounding down with the math.floor method, and the modulo operator. So we've been given a brief walkthrough how we might use all of these together. If a user was to enter in 15 cents, and we have a gold coin that is worth 10 cents, if we use the division operator, we'll say that 15 divided by 10 is 1.5. However, we can't divide coins in half. So instead, what we're going to do is round down to the nearest whole number. So 15 divided by 10 in parentheses is 1.5, and if we use the math.floor method on the number 1.5, we're going to round down to the nearest whole number, which is 1. So once we round down to the nearest whole number, we know how many of the 10-cent coin that we need. But we need a way to calculate how many cents are left so that we can divide that into a smaller coin, such as the 5-cent coin. So we can do that with the modulo operator. We could say 15 modulo 10, the 10-cent coin, leaves a remainder of 5. Alright, so that's everything we need to get started. So let's go ahead and start on the first task. We're going to run the code once to understand the starting code. So I'm going to go ahead and save the code that we have here. And then I'm going to type in .NET run. So currently we have a console.writeLine method that is printing out to the console, welcome to Moneymaker. Let's move on to step 2. And before we get started coding out step 2, I'm going to go ahead and just put a comment here. Greet the user and get input. That's what we're going to be accomplishing over the next several tasks. So for step number 2, we want to ask the user for the amount to convert and capture the value in a variable. So we'll say console.writeLine, and we'll pass in a string that says enter an amount to convert to coins. And we'll make sure to end this with a semicolon. And I'm going to save my code really quick and also run .NET run, just to make sure that my text is coming across as I would like. Welcome to Moneymaker, enter an amount to convert to coins. Okay, so now we want to create a variable. We'll call this string total as string. This is where we're going to collect the user input that they've provided and do math on it to provide a final answer in the end. I've named this variable total as string and given it a type of string, because what the user provides when we use a console.readLine will actually be a string value even if they're just typing in a number. And then what I'm going to do, just so we can make sure that we can check our work, is I'm going to console.writeLine, and I'm going to pass in this total as string variable. So I'll go ahead and save my code. Then we'll say .NET run. And we get our welcoming messages. I'll put in the number 25. And when I press enter, we can see that line 13 of our code actually prints out to show that we've captured the number 25 as we would expect. The only problem is that this number 25 isn't actually a number, as we said, it's actually a string. So let's mark step 2 as complete and move on to step 3, where we want to convert our string to a number. So I'm going to go ahead and remove line 13. And if we want to convert a string to a number, we'll do that by creating a new variable. It'll be a type double. We'll give it a variable name of total, and we'll set it equal to convert because we're going to convert a string to a number. And we'll use the toDouble method, and then we'll pass in total as string. Okay, let's mark step 3 as complete, and we'll go ahead and move on to step 4. Now we want to interact with the user to let them know that they've passed in their data as they would expect. So we want to print out to the screen whatever the user inputs, for example the number 16, the program should write to the console 16 cents is equal to ... So we'll say console.writeLine to print out to the console, and then we're going to pass in our value. And we'll go ahead and use string interpolation. And remember, string interpolation starts with a $sign in front of the opening and closing double quotes. And now to print out our variable, we want to print the value of total. We simply use opening and closing curly brackets and name our value that we want to print to the screen. So our total is equal to ... And we'll end this with a semicolon. Now let's go ahead and save our code. And let's go ahead and run our code. And we get our welcoming message. Let's go ahead and pass in 16. Alright, so we got 16 is equal to ... Okay, so we've already accomplished step 4. And if we look and see, we can see that we've actually accomplished step 5 as well. We wanted to run our code and make sure that there was the welcome message. And then once the user passed in their input, we gave the user an output message showing that things are working as the user would expect at this point. Okay, so let's go ahead and move on to step 6, converting to coins. So I'm going to go ahead and add a comment here. In step 6, we're going to define coin values. So we want to create a variable to contain the value of gold coins and a variable to contain the value of silver coins. So because coins are going to have a value that's a whole number, we'll want to use int. And we'll say gold value is equal to 10. And then another int, gold value is equal to 10. And then another int that silver value is equal to 5. And for now, we're not going to worry about the bronze coins, and that will make sense as we go further down this lesson to see why we don't need to do this. So let's go ahead and move on to step 7. In the next few steps, the basic task that we're trying to accomplish is how to calculate the change. So we're going to begin with finding the maximum number of gold coins that fit into the amount and figure out what's left over from that. So for example, 1 gold coin fits into 11 cents. So we'll go ahead and create a variable of type double. I'll call it gold coins, and we're simply going to set it equal to math.floor, and we'll take our value of total from the user input and pass it to our math.floor method. And we're going to divide it by gold value, which is 10. So if a user provided the number 16 as the total, and we divided it by the gold value of 10, we would get 1.6. But when we run that through the math.floor method, we would get 1, because we round down to the lowest whole number. So now we want to find the change. What's left over? So we'll say double remainder is going to be equal to total, for example, the number 16, modulo gold value. So 16 modulo gold value of 10 would be the value of 6. So that's our remainder, what we could think of as our change. Now what I like to do is just check that the values are coming across as we would expect. So I'll just do a console.writeLine, and I'm going to pass in gold coins, and then console.writeLine, and I'm going to pass in remainder. I'm going to save our code. Now I'm going to go ahead and run our code, and we get our welcoming messages. I'll put in the number 16, for example. Now my expectation is that we should get a message saying that 16 cents is equal to ... and then we should print out gold coins, which I would expect line 21 to say that 16 divided by 10 passed into the math.floor method would be 1, and then looking at line 22, 16 modulo 10 would give us a value of 6. So let's run our code, and it looks like we get exactly what we'd expect. So everything is working great. Let's mark step 7 as complete, and also step 8 as complete as well. Now let's go ahead and move on to steps 9 and 10. We're going to go ahead and repeat the exact same process so we can do this a little bit quicker. We'll say double silver coins is going to be equal to the math.floor method, because we want to get a whole number of coins, and we'll take our value of remainder and we'll divide that by silver value, which is 5. So in our scenario of 16 coins, we had a remainder of 6 after the gold was taken out. 6 divided by 5, the value of silver, would give us the number 1 point something. And when we run the math.floor method on it, this rounds us down to the nearest whole number of 1. So now we want to find out what the new remainder is. So we'll say remainder, which we've already declared the type, so we don't need to do that again, is equal to remainder modulo silver value. If we had a remainder of 6 and we use the modulo operator on the value of 5, that would give us a remainder of 1. So I'm going to go ahead and remove lines 23 and 24, where we printed out gold coins and the remainder, and I'm going to paste them down below, and I'm going to change gold coins to silver coins, and I'm going to leave remainder. So let's go ahead and save our code, and we'll run our code again. We get our welcoming message. Let's pass in the number 16, which will give us the message that 16 cents is equal to, and in this case, as we talked about, we're expecting 1 silver coin and 1 remainder. Let's see what we get. Awesome. Perfect. Things are going as we would expect. Let's go ahead and mark step 9 as complete, and we'll go ahead and mark step 10 as complete as well. Okay, now we're going to go ahead and remove lines 27 and 28. We no longer have to print those out. The last thing we want to do is we simply want to print the results of all of our coins. So we can do that with console.writeLine, and then we're going to use string interpolation. So we use $, opening and closing double quotes, and the text gold coins, and then we'll pass in our variable gold coins. In the case of the number 16, we would expect to see 1. Now we'll go ahead and console.writeLine, and we'll use string interpolation again, and we want to print a message about silver coins. So we'll say silver coins, colon, and then in curly brackets, we'll say the variable silver coins. And then you notice that we didn't do any math for the bronze coins. That's because the bronze coins are always going to be a number less than 5, which means that whatever the remainder is, that will be the amount of bronze coins that we need. So we can say console.writeLine, string interpolation, and we'll say bronze coins, and we'll just pass in, instead of a variable named bronze coins that doesn't exist, we'll pass in remainder. So let's go ahead and save our code. Now we'll go ahead and run it. And just to be consistent, we'll go ahead and pass in the number 16. Now if things work out as we expect, we're going to get a message that says 16 cents is equal to ... and then we'll print our results that a gold coin is a value of 1, silver coins are a value of 1, and bronze coins are a value of 1. So let's see what happens. Perfect, exactly as we would expect. Okay, so let's go ahead and return to our original challenge. We have these 3 types of coins, and we want to figure out what is the minimum number of coins that equals 98 cents. So I'm going to go ahead and run our code. and I'm going to type in the number 98. Now in our heads, we could probably do this. Now you could probably do that pretty quickly in your head if this was a more significant number of 1,253 cents or 25,964 cents. That math would take quite a bit longer to do in your head. Or we could just type into the console 98, and we can immediately see that 9 plus 1 plus 3 is 13. Okay, let's go ahead and return to step 11 and mark it as complete. And now for step 12. This is where you can test your application to make sure it works. Some test cases are provided below in the hint section, so you're given some ideas on how to make your app better. What happens if we run our code and the user provides a value of 16.2? You get gold coins 1, silver coins 1, bronze coins 1.2. That doesn't work because our coins have to be whole numbers. This is where you could use type conversion or a math method to round down the user's input to the nearest whole cent. But what if a user is thinking of another currency? For example, in the US, we have the penny, the nickel, the dime, and the quarter. If a user provided the number 78, we would expect different coin results for someone in the US. So these are all things that you have to think through as you're creating a program. Who are your users? And what ways might they use your program in ways that you would expect? But in what ways might they also use the program in ways that you might not expect? So when you're creating a program, you need to think through a few things. What input validation might you need to use so that when someone is using your program, they don't use it in the incorrect way, such as passing in decimals, as we just talked about. You also need to think about when you're creating a program, what are the needs of your users? We just mentioned that people in different parts of the world have different currencies. That's going to shape the way that you code your program. Alright, well, great job in this project. We have used arithmetic operators in C# to think through a user's need. Imagine the other programs you could use arithmetic operators for. Maybe it's to record the number of miles you run per week, or a tip calculator when you and your friends go out for dinner. The programs that you could build for everyday life are limitless. Great job. This is Rob with Codecademy. Happy coding.